guys, welcome to this video. Today I think it's a good time and day to show you guys how we at my operator fly a non-precision approach using LNAV and VNAV. So I thought I'd take you through all the steps. So right now we are actually at a low altitude, but I've set up a holding and we haven't set up anything for this approach. So I thought I'd take you through the steps here. What we're going to do is I'm going to show you exactly step by step on how to fly it. I'm not going to follow the exact procedures in real life, and what I mean by that is the two-pilot cockpit, because doing that then it would take half an hour with all the briefings we have to do. So take this video today as the technical steps in order to get the 737 to fly a non-precision approach, and in our case it's going to be an RNP approach. But what we're going to do today is the exact same steps for every single non-precision approach you can fly. Alright? So it doesn't matter if it's a VOR, an NDB, or what it is. Doesn't matter. You can fly it in the exact same way. Okay, just for good measure here. Altimeter is okay, we're passing 103 for flight level 6010 checks, and let's do it. So fuel is nicely balanced, 4 pumps on, lights are coming on. APUs off, angle of bank 25, pressurization we have 4.6 and the descent panel is set. You can seat the crew here, sorry, the passengers. Demonitor 1215, log off CPL 10 checks completed. Great. So guys, what is a precision approach and what is a non-precision approach? Well, if we have a look here. Today, listen to my words, but don't take it too heavy, okay? Because what I'm gonna say is just a rough estimate, okay? So, a precision approach is something with a established ground aid, which can precisely guide you down towards the runway. A few years back, the only precision approaches we had was ILSs. Cat 1, Cat 2, Cat 3. Those are precision approach. Now, a non-precision approach is defined as an approach that does not necessarily use a ground aid, or does use a ground aid but only gives you lateral guidance. So in this case, an NDB or a VOR approach gives you nice lateral guidance, but the vertical guidance is based upon, for example, altitude versus distances. So in this case, you can see that DMEs at 6 miles, 2,000 feet, 5 miles, 1,675 feet, and so on and so forth. So we don't have a dedicated glide slope. We have a calculated one here. So at 6 miles we can be at 2,000, 5 miles, 1,675. This is calculated to be a safe area. So this is a non-precision approach. Now, the RNP approaches used to be classified as a non-precision approach all around. But correct me if I'm wrong, I believe that now EASA has approved RNP approaches with LPV minimas to be considered and flown as precision approaches. Does that change anything for us? Not at all. It only changes the minimums. Now, the 737 that I fly is not LPV approved. We cannot fly non-precision LPV. What we can fly is LNAV VNAV minima. LNAV VNAV minima gives us a great diversity because some airports cannot fly LPVs anyway, but they are approved for LNAV VNAV minimum, so in that case we can fly it. So at my operator we are LNAV VNAV minima approved on non-precision approaches, which means we can fly non-precision approaches pretty much anywhere. Good. So looking at the plate here, it's very similar to a precision approach. The difference being, none of this is based upon a ground aid. Had it been based on a ground aid, this would not be an RNP approach, it would be a GLS approach. Good. So what we see here instead of a localizer and glide slope channel is a EGNOS channel. That is the system, the GPS system we use here in Europe, EGNOS. And we can see it's on channel 48468 and Echo 28 Alpha. Does that matter to us? No, it does not. What we use this for is to calculate a RAIM check, and the RAIM is the precision and availability of the satellites. So as you can imagine, one satellite can give you a nice time. Satellites work by sending a time out to your recipient, and then the difference in the time is calculated, and then they know exactly the position. But we need a certain amount of satellites to fly a non-precision approach here, GPS approach. Now, before we do this, if we expect to fly a non-precision approach during flight, we check on our EFB on the ground that we have a RAIM check. And the RAIM check is calculated daily and I think even hourly. Look at the speed here, I should fix it. To calculate if there are any expected outage of satellites. Now in our case today, that is not a problem. We have all the satellites we need. I think we have 17 or 18 satellites and I think we require 5. So we are very, very good to fly this RNP approach. So that is kind of like the first thing here. The next thing we want to do when we set it up. Let's go to the pilot flying seat here. Now we're entering the hold here, just so we have some time and I can show you everything. We want to have a look at our final approach course, 277. Now when you guys set a final approach course, remember it is a final approach course. It is a final approach track. It is not the final the runway heading. So what I would do is when I set this one, I would have a glance at the airport chart and I would zoom in. And in this case we can actually see that the runway heading is 276. That means when we set the runway heading on the MCP, when we established on final, we set 276, not 277. Great. The next thing that we're going to use is our minimap. In our case today, you can see it's a decision altitude. It's not an MDA. So that means we can set the 385. We do not need to add 40 feet. So let's set 385 here. .385 is set. The QNH for Aarhus was 1027. Happy days. Good guys. So now we need to talk a little bit about the threats of a non-precision approach. I don't know if you have ever heard this term, but we have something we call QNH blunder error. Basically what it is a non-precision approach like the GPS approach, VOR approach, anything like this. It is based upon the barometric altitude, whereas the ILS, it doesn't give a damn about the barometric altitude, because we have a fixed ground station on the ILS sending up a 3-degree beam up into the air. If we catch that, we're on the correct path. 9 out of 10 times, you know, because we do have false glide slopes as well. That's a different story, but QNH blunder error is because the glide path of this is calculated according to the GPS distance to the runway and the altitude you have set with reference to your barometrics. This means that this runway point right here can be changed. If we have the incorrect QNH set, we will end up high or low. So that means that everything in the FMC, if we go to our descent page, if we go to our progress page 4, our vertical deviations, our RNP, everything will look correct. Our altitude will look correct. The altitude versus distances will look correct. But our true altitude will be a lot different. It can be either too high or either too low. If it's too high, well, at minimums you're not going to see the runway. We go around, we figure out what the hell went wrong here, and then that's it. The negative thing is if we're too low, then we're going to fly ourselves straight into the ground. With everything looking normal, we're going to fly ourselves straight into the ground. Now, there are a few mitigations here to mitigate this error here. First thing, I would like to show you here what I'm talking about, okay? So we have the runway here, and in green, we have our 3-degree path up until our altitude, okay? 2,000 feet. And in blue is our mean sea level, okay? So this is where we expect the ground to be. This is our runway. And this is our 3-degree glide path with the sample line there. Good. So the thing is, the barometric references a QNH is based upon the mean sea level pressure. Good. So if we change the QNH setting on our altimeter, we can have, for example, let's say we set another QNH we can actually move this barometric reference. So as you can imagine now, if we moved our barometric reference, our mean sea level now, we have moved this line, but we have not moved the runway. That means that when we think that we are going to be approximately at this point right here, let's say this is going to be 500 feet. Where is the ground, guys? Well, the ground is right here. So we're going to fly ourselves straight into the ground when we expect the runway here. That is QNH blunder error. And we can mitigate this. We can mitigate it by a few different ways. Let me create a new one here. If we have a look back in our flight simulator here, we can see we have something called a VSD. On the VSD, if we zoom out far enough, you'll notice that when it has loaded, you can see we have a terrain line here. Now there's no terrain around this area, so it's quite flat. But this terrain line, we should have the runway placed right on top of it. That is our main way of mitigating QNH blunder error. So if we go back to the sophisticated explanation tool here, if we imagine we have our VSD in this box here, maybe we have a bit of terrain here, and then we have the airport. Then at some point where we have the runway, it's going to be a white box. It should be positioned exactly on the terrain floor. If it is that, then we know that we've set the correct altitude, because this terrain is based upon the terrain database, not reference to the mean sea level. Good. Now, the second way of mitigating it is when we fly the approach. So, if we have the runway here, we put in usually a 4-mile ring for VMC and a 10-mile ring for IMC. So this is going to be a mixed 2D and 3D picture, okay? So this is of course our final approach track. And this is the side picture of our glide slope, okay? So, normally on a 3-degree glide path, we expect the 2,500 feet RA call at approximately 7 to 8 miles. Between 6 and 8 miles, roughly around 7, okay? So let's say 7 plus minus 1. And that is because it changes a little bit with the topography of the terrain under us, okay? So if we have a high terrain here around 7 miles, we'll get it slightly earlier. But roughly around 7 miles. So if we get it at 12 miles, we'll have a big problem. So those are the two things. Let's get back into the simulator. So now we talked about QNH blunder error and how we mitigate it. So we expect at roughly 7 miles, we expect the RA call of 2500, and we expect on the VSD to see the terrain above, exactly on the terrain actually. Good. So let's go back here for the setup of our approach. Runway point we have, 4-mile point, 10-mile point. We don't need a descent point today. I'll put a 25-1 just for reference, just to know how far out we are. Good. So we have the frequencies, we have the rings, we have the idents, we have the standby altimeters and courses. 277, 277. Good. So let's talk a little bit about VNAV. We're going to fly this approach in LNAV, VNAV, VNAV path with speed intervene. It is very, very important that we have VNAV path before we establish ourselves and cross the final approach fix. If we do not have VNAV path, well then we're going to descend in a VNAV speed, which is going to be above the intended path of flying here, so we're going to fly an unstabilized approach, and this is a mandatory go around. Good. So, we're going to fly it in LNAV, VNAV, VNAV path with speed intervene. What we want to do is, we want to at some point make sure the aircraft is going to descend us all the way down to our minimums. The way we are going to do that is 2 miles prior our final approach fix, I want to have my pilot monitoring call me approaching descent. When he calls approaching descent, which is 2 miles prior the Alpha Hotel 281 point, I will set the the revised MDA, which is going to be 400 feet. So I'll set 400 feet in the MCP. I'll verify LNAV, VNAV path, and speed intervene, okay? And when we cross the final approach fix, I will call VOF altitude if we have any flags or if we have no flags on the altimeters. And then we're going to start our descent. At a 1,000 feet above aerodrome elevation, which is going to be the start of the white bar, is the latest point at which I will recycle the MCP selected altitude to the missed approach altitude. And that's the thing with certain criteria in VNAV when flying these approaches. You can reset the altitude. So this is the only exception where VNAV is going to bust the selected MCP altitude. If you do this correctly, VNAV will take you all the way down to the minimum use height of the autopilot for this approach while staying in VNAV with a higher altitude selected. I'll show you on the approach, okay? That is basically it. So actions with visual, we wanna just fly this all the way down with the flight directors on, because we have a runway point, so we will get a rough vertical guidance all the way down to the runway. Actions if not visual, well, I'll press toggle once, call go around flap 15, set go around thrust, 400 feet LNAV, 1000 feet, correction, tune the radius missed approach, 1000 feet, we raise the flaps, and we're gonna fly the published missed approach, which is climb straight ahead, Alpha Hotel 284, turn right to Badut, climbing 4000 feet. Good. So that is the missed approach as well. That is pretty much all the steps, guys. So let's continue to Badut here. Let's start our descent. So, Frisk, we just need some landing performance here, so a difference of 100 to 62.4, flaps 30, auto brake 3, there you go. Let's say we're cleared 2,000 feet here, which is going to be our platform altitude, so we set 2,000. You can see 2,000 via Urupa is our platform altitude all the way to the final approach fix, okay? So already now we can see we are catching up our VNAV path, we're in VNAV path, we have the speed under control, and we're in LNAV. So we have all the modes selected where we run right now. Now, the pilot monitoring should have the VSD open at all times so that the pilot flying can reference the path and also call if the terrain is in sight when we are gonna come closer to the runway. So now we are back in VNAV speed here because we're a little bit above the path. I'm just gonna help the aircraft get back on path here. Coming in nice and slowly, and we should catch VNAV path any minute there. There you go. As you can see, VNAV is nicely trying to get rid of our energy here, rid of our speed, before we start the approach here. So at this point I actually want to have flap 1. So I call for flap 1 and pilot monitoring says speed check flap 1. I want to already now go speed intervene here and set my flap 1 speed. Now my reference now is going to be 200 knots by the 10 mile, and from 10 miles we can take, for every mile we need to decrease the speed 10 knots, so at 9 miles we want to be 190 knots, 8 miles 180, 7 miles 170, so on and so forth. That means that at 4 miles we're going to be 140 approximately, which is pretty roughly close to our final approach speed, which is exactly where we need to set it. So that helps us a little bit there. We can go flap 5, I'll keep the flap 1 speed though, just because we are pretty low on energy right now and have a little bit of spare, so it's all good. Good, so we're cleared for the approach. When we are cleared for the approach, the pilot flying wants to monitor the RNP progress. To fly an RNP approach, we want to have RNP 0.3 set down here, and it is, which is good. We can see the actual RNP is 0.07 nautical miles, so it's very, very precise compared to what we actually need. This is what we monitor. If we get any flags that has anything to do with the RNP, then we need to go around. Okay, we cannot fly an RNP approach without this being precise. And as you can see, we have a vertical deviation here, which is based on our true path, which we will closely monitor. Look, this is only correct with reference to the QNH, okay, with the mean sea level. That is why we need to mitigate the blunder error. Good, so guys, do you remember which point we needed to call him approaching descent? 2 miles prior Alpha Hotel 281. With turn on final approach course, I'm gonna set the runway heading, which we agreed was 276. So now the pilot monitoring is the one that's gonna have the next job here. We want to closely monitor Alpha Hotel 281, and when we're 2 miles prior to that, we want to call to our pilot flying approaching descent. And this might get a little bit busy at some point, guys. $2,500. How far are we out? We are 9 miles, 8 miles, so that's perfect. So terrain is noted, and we can see here that the runway point is exactly on top of the terrain. So now we've mitigated QNH blunder error, okay? Approaching descent, alright. Revised MDA, 400 feet set. VNAV is path, speed intervene. Good. So now the next job is for the pilot flying to do his checks above the final approach fix. Cabin crew, seats for landing. Notice how we didn't use the approach mode, guys, on the standby altimeter. That's because it has only reference to the localizer and glide slope. We don't have any of that. Okay, so 0.4 to go, 0.3. And we need to be at 2,000 feet. Final approach fix, 2,000 feet, no flags. And actually the right call is FAF, 2,000 feet, no flags. Pilot monitoring will verify altitude, checks, no flags. Great stuff. Next step for the pilot flying is going to be at 1,000 feet. We want to reset the missed approach altitude. Whereas for the pilot monitoring, we should reference distance to 28 left, 5 miles, 1720, 4 miles, 1405. So next time 4 miles is going to be 1405. State that to the pilot flying, and then we can call if we're on profile. Okay, configure a little bit early, gear down, flap 15, landing checklist to flap start switch is continuous, recall check, speed brakes is arm green light, landing gear down, free green, auto brake free set, flaps 30 please. Flaps 30, 30 green light, landing lights on, clear to land, and reset the missed approach altitude at 1,000 here. We heard the call, 1,000 feet, missed approach altitude 4,000 feet is set. Verify on the FMC. And that is it, guys. Now we've completed everything. As you can see, we have 4,000 feet set in the MCP. We're an LNAV, a VNAV, descending towards the runway, and it will keep us descending here, all the way down to the runway. Now PUP is in sight, we don't need any more callouts, we can disconnect everything here. And then we can fly pretty much visually here, but we can also use the flight director guidance to get all the way down here. I feel like I'm a little bit low, so I'm gonna correct just a little bit. And we want to check the speed as well.
Plus 100.
Checked.
Minimums.
Continuing. Correcting.
$50, $40, $30, $20, $10.
Okay, speed brakes are up. Reverse is normal. 75%. 100 knots, 80 knots, manual braking, 60 knots. So that is exactly how we fly a non-precision approach, in this case an RNAV approach. I hope you learned a thing or two, guys. The only thing to mention is if we don't have a runway point in the FMC for the non-precision approach, then we have to recycle the flight directors, okay? So in our case today we did have a runway point, so we could continue like this with flight directors on, but if we didn't have a runway point, you need to recycle the flight director and fly it from when you disconnect. You want to recycle the flight director and fly it like a visual approach. That is it for today, guys. I really hope you enjoyed this one. It was a pleasure to do this one. I am really busy and I'm trying to put out as many videos as I can, but I am super busy. But I hope you guys enjoyed, learned a thing or two. As always, if you have any requests for videos, this one was a request as well. Please let me know below. If you learned a thing or two, let me know. And if there's anything I can learn that you think I missed, please let me know below. Thank you very much, guys, and see you in the next video, okay? Bye!